So if we look at the question 1A from this assignment, which I believe is 2A from our first homework assignment, we're looking at double addition. And the question is the addition associative? And what it says is, it starts by saying we'll call what associative according to double addition, plus the left side. We have our left side and we have our right side. And then we see that these are not equal, taking A equals 1, B equals 0, C equals 0, and I get this expression of 2, 4, and 2 and 4 are not equal. Now, here, the proof sketch does prove what's being asked. The proof sketch is clear and easy to understand. There's enough detail that it can be understood, but not too many detail that it distracts the reader. So it would get 2 marks for correctness of proof and 2 marks for clarity of sketch. However, with it, it doesn't get the 2 marks for the initial state and goal. The initial state and goal are properly defined. We're trying to see if it's associative, but it doesn't quite conclude by stating that it's not associative because they're not equal. There's a little bit of detail missing at the end that the reader should be able to see. Oh, yes, that does prove it, but it doesn't clearly state, hey, I've not proven it. But it also doesn't explain at the beginning how you're going to do it. So the initial state and goal problem is clearly defined and the proof technique is clearly given, but not at the beginning of the proof sketch. Not at the beginning of the proof sketch. This is really where this is going to lose marks. This is going to lie somewhere between a 1 and a 0. It's not extremely clear exactly what we're showing. So there might be 0 marks for the proof sketch, or the proof technique missing from the proof sketch. That might be a 0. But here, this statement, we see that these are not equal, taking blank, we get blank. That might save us and give us a 1, but this would be sitting around a 4 or a 5. Now, if we look at this, we've got this explanation. This here, we're given complicated multiplication of real numbers, where addition and subtraction and multiplication are the usual operators. And determine with proof if this addition is associative. And we claim that it is associative. And we let there be 3 real numbers. And then we look at the addition and multiplication, or the dot box operator in these way, in the left and right side, sorry. And it goes straight into expanding the left side of this equal sign, expanding the right side of the equal sign, and then comparing them to each other and showing that they're equal to each other using the distribution. And since both expressions, the first and the second, are equal, they have shown they're equal. So here, the proof sketch is very clear. It does prove what's being asked. It's very clear and easy to understand. There's enough detail, but not too much. Again, 2 marks here, 2 marks here. Once again, the initial state and goal is what's missing. At the beginning, it says we claim it's associative. They state what the goal of the problem is, what the initial state is. They give what the initial state is. We've got these 3 real numbers. But they haven't clearly stated the proof technique used, or how they're going to solve this problem clearly at the beginning. And they do explain the proof technique as they go along. Compare this to the second addition. They explain how they're going to prove it as they go along, but it's not at the beginning. So once again, that's why this would, in my opinion, be getting a 5 instead of a 6. It'd be losing a mark for at the beginning of the proof sketch. Now, again, because it's not the clearest about the proof technique, it doesn't explicitly state boom, this is the proof technique. Some may lean toward giving this a 0. Now, because we're really focusing on this proof sketches of the clearly what proof technique you're using and explaining quickly how you're going to prove it, taking a solution like this, and going from a 5, maybe a 4 to a 6 is not terribly difficult. Just at the beginning, we introduce the goal and how and what we want to show and what we're given. They have to a good degree, but we just add one sentence here about how we're going to prove it. One short little sentence, and boom, it's a 6, done. So a lot of the times to get your proofs from a 4 to a 6, the 4 is the meat of the problem, and a 6 is just introducing what you're given, you want to show, in a brief summary of how you're going to show.